In this segment, we'll introduce you to the 4 most common mold rubbers used today and offer advantages and disadvantages for each. Latex rubber offers the advantage of being the least expensive mold rubber available. Latex molds are very elastic, thin-walled, and strong. They last a long time and offer good abrasion resistance from casting materials like concrete. Because latex is so elastic, it is good for making glove molds, which means the rubber can be turned inside out and removed from a casting like a glove. This can save time if you are doing production casting. A disadvantage of some latex rubbers is a strong ammonia smell that some find unpleasant. Another possible disadvantage is that latex can only be brushed on to an original. You cannot pour latex. Also, many coats are necessary to build an adequate mold thickness, often 20 or more, with drying time necessary in between. Which is why making a latex mold can take up to 2 weeks. Another disadvantage is that many latex rubbers shrink. Shrinkage in your mold can mean problems when casting into it. Latex rubber is good for casting concrete, wax, or plaster. Latex is generally not used for casting urethane, polyester, or epoxy resins, or low-temperature melt metal alloys. Molds made of polysulfide rubber are soft, stretchy, and durable, and they last a very long time. Polysulfides are of moderate cost and will cure against water clay or clays containing sulfur. This is something that neither latex, urethane, or silicone rubber will do without adequate model preparation. A disadvantage of polysulfide rubber is that an accurate gram scale is necessary to weigh components, an added cost that you must factor in. Most polysulfides also have an offensive odor. Polysulfides are black and may stain white plaster during casting. Molds made from polysulfide rubber are good for casting plaster or wax only. They will not handle the abrasiveness of concrete, chemical harshness of resins, or the heat of low-temperature melt metal alloys. Silicone rubber has the best release properties of all the mold rubbers. Not much sticks to silicone. This means that model surface preparation before applying silicone rubber is minimal or not necessary. Also, applying a release agent to the surface of your cured silicone rubber mold before casting is often not necessary. Silicones also offer the best heat resistance to high temperatures. You can cast low-temperature melt metal alloys such as tin and pewter into silicone rubber molds. Of the mold rubbers we are introducing, silicone is the only one that can handle these high temperatures. Silicone rubber offers the mold maker the advantage of high tear resistance. With high tear strength Mold-Max and SmoothSil silicones, if a tear develops in the rubber, it will be terminated at a knot, and you can continue to use the mold. This is known as knotty tear propagation. Silicones also have very good chemical resistance and will give you the longest mold life when casting urethane, polyester, or epoxy resins. A disadvantage of using silicone rubber is the price. Of the mold rubbers we are introducing, silicones cost the most money. Like polysulfides, high tear strength silicones require precise measurement. If you are going to use silicones on a regular basis, you will need to invest in an accurate gram scale to weigh components. A good gram scale can cost anywhere from $75 to $200. High tear strength silicones are usually thick, which means that they entrap air. unless the air is removed from the silicone mixture before being poured over a model. You may end up with bubbles in the finished mold, and these bubbles will be reflected in each casting taken from that mold. To remove the bubbles, silicone rubber is vacuum degassed after mixing. A vacuum chamber and a vacuum pump is required for this, which means another investment of between $800 and $1,000. There are two types of silicone rubber products available for making molds. One is known as tin-cured silicone, which is the most widely used. They are great for casting almost any material. Tin-cured silicones will shrink somewhat over time, and if left for a long time on a shelf in your mold library, they will lose tear strength and eventually become unusable. The other type of silicone is platinum-cured silicone. These are premium mold-making rubbers and are the most expensive available, but they absolutely do not shrink and will last for many years in your mold library. Be careful when using platinum silicones, as they are easily inhibited and may not cure against some models. Polyurethane rubber is available in a wide hardness range, from softer than your skin to harder than a car tire, and every hardness in between. Most polyurethane rubbers last a very long time. They cost less than silicones and polysulfides. They cost more than latex. Many polyurethanes are mixed by volume, meaning that you do not need an accurate gram scale to use them. Urethanes also de-air themselves, meaning that you don't have to vacuum degas them before pouring. As silicone rubber has the best release properties, urethane rubber will stick to just about any model. It is especially important to prepare the model surface so that the rubber will not stick to it. Also, before casting into a cured urethane mold, application of a release agent may be necessary to successfully release the casting. Urethanes are moisture sensitive, meaning that they may bubble or even foam when exposed to humid air. This moisture sensitivity means that once containers are opened, urethanes have a very limited shelf life, and you should use what is left in the container as soon as possible after opening. Polyurethane rubber is good for casting wax, plaster, concrete, and resins. Urethane rubber will not handle the heat of low-temperature melt metal alloys.